We're going to be reviewing Unit 4 today. Unit 4 was on evolution. So you want to go ahead and turn to Unit 4 in your handbook. And this is where we're studying how does life evolve and what evidence do we have of that. So the objective is explain how fossil, biochemical, and anatomical evidence support the theory of evolution. And so when we look here, we didn't spend a lot of time talking about Louis Pasteur, but he did help us understand biogenesis. Biogenesis is where life continues. And life continues today. So if we look at where life comes from in today's world, life reproduces. We see that one cell divides and that makes more cells. We use sexual and asexual reproduction to reproduce. And so on today's earth, we use biogenesis. However, Miller and Urey's experiment helped us understand abiogenesis. The fact that non-living molecules like gases such as CO2 and liquids such as water can form organic molecules.
Tracy Hales, please call the front office. Tracy Hales.
Could form cells. And so this picture for you is going to be really hard to see, but if you go back to the picture in your notes, you should be able to see it a little bit better. This is the picture of Miller and Urey's experiment where they had water and a bunch of gases. They chose these gases because these were the gases of early Earth. What's important is that early Earth had no oxygen. And so if you look at this diagram of Miller and Urey's experiment, there was no O2 or oxygen there. When they added boiling water, these gases, and energy, such as from volcanic eruptions, they actually found that amino acids would form. If amino acids would form, we would find that organic molecules, such as proteins, carbs, lipids, and nucleic acids, could form cells. And so this is where we think abiogenesis came from. So that's where the very first cells might have come from. And now we want to look at what's called the heterotrope hypothesis. Most hypotheses state that prokaryotic anaerobes evolved first. Anaerobes because there was no oxygen available. The hypothesis then suggests that prokaryotic autotrophs probably evolved. Why did they evolve? Mutations allowed for photosynthesis. And so if some organisms had mutations, then they were able to perform photosynthesis. What would happen because these autotrophs perform photosynthesis is we would actually get oxygen gas. And then we would get aerobic heterotrophs. And these cells can perform aerobic respiration. The hypothesis that explains how eukaryotic cells, notice these are all about prokaryotic. Eukaryotic cells is from what's called the endosymbiont theory. The endosymbiont theory is that small cells lived together. And remember, we have evidence for this. If you look at the mitochondria and you look at the chloroplast, they have their own DNA. And so that's evidence that the mitochondria and the chloroplast might have once been their very own cells. Next, we talk a little bit about fossil evidence, and this I'm going to leave for you to fill in. So please make sure that you go back and you fill in these using your notes. How do the following pieces of evidence support the theory? If you'll circle anatomical and biochemical, and if you will, put a star by this and explain how do anatomical structures support evolution and how do biochemical evidence support evolution. Remember, it's purposeful, but I'm asking you to now go back to your notes. Next, we have a little bit about natural selection. Explain how natural selection influences the changes in species over time. Discuss the steps in Darwin's theory of evolution. Populations of organisms have many genetic variations. And so when I look at a population, remember we learned this word, a species. When I look at one species, they're going to have variation. And remember that comes from what are called random mutations. You can't wish and hope for a mutation. If someone falls off a bridge, they can't wish and hope to have a mutation and have wings. That just doesn't happen. This is why natural selection can be very random. Populations could reproduce exponentially, but they don't. Remember, exponentially is a J curve. Our populations don't produce in a J curve because we have limiting factors that cause competition. Genetic variations lead to different adaptations. What are adaptations? It wants you to define, so you do need to answer what is an adaptation. And some adaptations have better survival value. What does it mean to have better survival? We also call this adaptive value. Because remember, it's not just enough to survive. You also have to survive long enough to be able to, and you should be able to fill that in. What does it mean to be fit in an environment? And why will the frequency of selected genes increase? So if you have some organisms that survive long enough, why will that gene increase in frequency? Remember, frequency means number. Why will the number of that type of gene increase? When this process continues over millions of years, it can lead to speciation. What is speciation? So again, you're going back to your notes and you're purposely trying to read back through those notes and look at some of the answers to those questions. The last part of the notes is actually looking at how disease agents can influence natural selection. Describe how a bacteria, whoops, too far. Describe how a bacteria can become resistant to an antibiotic or an insect to a pesticide using the steps above. I want to get you started out. Remember, first, there has to be variation in the population. So some are going to have mutations, or some are going to be mutants. And so you should be able to tell me how a population of bacteria will change over time. Explain why new flu vaccines. Reminder, flu is caused by a virus. And viruses do something a lot. Viruses will actually mutate very quickly. And that's why we need new flu vaccines every year. Excuse me. What I want you to do here is actually tell me the difference between active and passive immunity. Active immunity is where you make antibodies. Passive immunity is where you are given antibodies. A vaccine is where you're exposed to a virus or a bacterium, etc. Virus or etc. So if I give you the virus, am I giving you antibodies, or is your body going to make antibodies? Remember, if I give you the virus, your white blood cells will attack it and make these little tags. So vaccines are an example of active immunity because your body will actually make antibodies for it. Explain the relationship between sickle cell anemia and malaria. remember, is a genetic disease. It's actually co-dominant. And your red blood cells are sickled. Well, malaria is actually going to infect your red blood cells. If they're sickled, you can't get malaria. So people who have sickle cell anemia, or people who are normal and sickle, who are heterozygotes, they won't get malaria because they're protected by the sickle cell. This last part is actually going to be in section 4, so we do want to talk about it real quickly. Talking about the kingdoms and the domains and the classification level, you should be able to do this. It really comes directly from your notes. So just go back to section, this is going to be section 4.3. You want to go here and look up all of that information. And then finally, the very last part looks at phylogenetic trees and dichotomous keys. So again, I'm not going to tell you the answers, but you do need to do these two problems with the phylogenetic tree and the dichotomous key. And this is where we'll stop for today, but make sure that you got all the way through everything that's on the board.